To solve this system with Gaussian elimination, we need this in triangular form. So we need everything below this line here to be a 0. So I'm going to get rid of this 2x, and I've got a 2x here as well, so I can do both of these essentially in the same way. We can use equation 1, which just has an x right there, and subtract 2 of that. So we'll take equation 2 and subtract 2 times equation 1, and that'll be our new equation 2. Okay? And we can do the same thing for equation 3. Take equation 3 and subtract 2 of equation 1, and that will be our new equation 3. So our new system of equations, the first equation is the same, nothing changes there. Our second equation, we have 2x minus 2x is 0. Y minus a negative plus 2y is 3y. And then here we've got 4z minus 10z is negative 6z. And then 2 minus a negative again is plus 4 is 6. And then with equation 3, same thing, 2x minus 2x is 0. 4y minus negative plus 2y is 6y. Negative 2z minus 10z is negative 12z. And then 8 minus a negative is plus 4 is 12. So I've got my zeros right there. And now I just need to get a 0 in this spot right here. So to get rid of this 6y, I can use above it this 3y and just multiply this by a negative 2 to cancel that out. So we'll take equation 3 and subtract 2 of equation 2 to get our new equation 3. So my first equation stays the same, and my second equation stays the same. And now here I have 6y minus 6y is 0. Negative 12z minus a negative is plus 12z is 0. So I've got a 0 on the left side here. And then here 12 minus 2 times 6 is minus 12, and that's also 0. So I've got rid of this third equation completely. And so what that is going to lead me to do is say when I'm doing my back substitution, I don't actually have anything for z. So z can be anything we want it to be. Sometimes people will just leave it as z. Sometimes people will use a parameter, which is just some other dummy variable. And so we're going to say let z equal t. All right, that's our parameter. Now we can solve for y in terms of t. So the second equation becomes 3y minus 6t equals 6. And now add 6t to both sides. We get 3y equals 6t plus 6. And then divide by 3, and we get y equals 2t plus 2. So that's now our solution for y in terms of that parameter t. Our first equation now, we can solve for x, plugging y and z in terms of that parameter. So we have x minus y, which is 2t plus 2, and then plus 5z, or 5t, equals negative 2. So if I distribute that negative, I have x minus 2t minus 2 plus 5t equals negative 2. We can add 2 to both sides, and that's just going to cancel out this negative 2 completely. If we combine negative 2t plus 3t, we have just plus 3t. So x plus 3t equals 0. And then subtracting 3t from both sides, we get x equals negative 3t. And so that is our then solution in terms of that parameter. And we can write that as an ordered triple, our x, y, and z. So we have an infinite number of solutions here, and they are all of this form. So we could pick any value for t, any real number for t, and we would have a solution.